Good afternoon, everyone. We are group number 77, and we are presenting our project today titled Anomaly Detection in Credit Card Transactions using CNN. So, as you all know, fraudulent transactions are increasing globally, and detecting them is challenging due to their rarity. About 0.1% of all the transactions are fraudulent. So traditional fraud detection methods fail to adapt to the constantly evolving fraud patterns, which is why we aim to build a CNN-based model to automatically detect anomalies in transaction data. So for the data set, we use the PaySim credit card fraud detection data set from Kaggle itself, which simulates mobile money transactions. The dataset contains approximately 6 million transactions with features like balances, amounts, and transaction types. So for the input and output, for this model, we used features like transaction type, amount, and balances. The target variable is fraud, which indicates whether the transaction is fraudulent. The data was pre-processed to handle skewness and outliers by applying log and scale transformations. Talking about the EDA, we focused on understanding the distribution of fraudulent and non-fraudulent transactions. We performed univariate analysis. We also performed bivariate analysis. uh, Through univariate analysis, we calculated skewness and kurtosis for the features like amount and balance. So now over to Dhruv for explaining the baseline models.
So after performing the initial EDA and before moving on to our neural network, that is CNN, we tried on some baseline models such as logistic regression and random forest classifier. So in logistic regression, we fed the data and based on that, it was able to predict well that the transaction is either fraud or not. But the problem with logistic regression was it was not able to detect complex or tricky patterns. So we switched to a random forest classifier, wherein we made a bunch of decision trees, and this decision trees were segregated based on the features that we selected from the database. And based on the outcome of the majority of the decision trees, our model predicted whether the transaction is fraud or not. So this model and both the models performed well, as you can look at our area under the curve score. Then we switch to a convolution neural network, and I'll explain what the basics of CNN is. So initially, traditionally, CNN is used for identifying, classifying images well, but it can also be useful for our credit card fraud detection because there are a lot of patterns within our data. We can actually transform it into a 1D layer and feed it into a CNN network, and it can do a binary classification on the data well. So that's the reason for using CNN for credit card fraud detection. And to perform the CNN, we required some data pre-processing, which included doing a SMOT analysis. Because the data was highly imbalanced, we added some fake values and we also scaled the data to ensure that the features are on the same scale. So now Pritish should explain the architecture.
The CNN model consists of several layers, and the layers are input layer, convolution 1D layer, max pooling 1D, flattened layer, dense layer, and output layer. The convolution 1D layer detects patterns in the data, which are like unusual transactions. The max pooling layer reduces the size of data while retaining the important features, and the flattened layer converts the data to one-dimensional array while the dense layer fully connects the layers that makes the final decision. Moving on, let's talk about the train about how we train the model. The model we trained was compiled using the Adam optimizer for efficient training. Since this is a binary classification problem, we used binary cross entropy as a loss function. Early stopping was also utilized by us by halting training if the validation loss didn't improve for 10 epochs. So the model achieved a training accuracy of 92%. So for testing, what we did was after training, we evaluated the model's performance on the test set. The model achieved an impressive test accuracy of 94%, meaning it correctly identified fraudulent and legitimate transaction 94% of the times. The accuracy and loss over epochs. To track the model's performance, we visualize how both the training and validation accuracy as well as the loss evolved over epochs. These plots show that the model improved significantly over time, with the loss decreasing and accuracy increasing, indicating effective learning. So to conclude, I would like to say that we demonstrated how CNNs can be leveraged for fraud detection in credit card transaction by automatically learning complex patterns in transaction data. CNNs provide a scalable and effective solution to identify fraudulent activities. The model's high accuracy showed its potential for real-world applications in financial security. Thank you.